Okay, so for this problem we have two random variables with a given joint distribution, and the question is to find the PDF for the sum of the two random variables, x plus y. Alright, so for this one we have a property that we proved in class. If we let z be equal to x plus y, then the PDF of z is equal to the integral from minus infinity to infinity of f of x z minus x dx. Okay, now in this case we're clearly not going from infinity to infinity. The PDF here, the joint PDF, takes values with x is between y equal, x and y have to be between 0 and 1, and furthermore x plus y has to be less than or equal to 1. So if I draw the line y equals 1 minus x, so x plus y equals 1, so y equals 1 minus x, that's going to look like this. From here's 0, 1 here to 1, 0 down here. And so I have this triangle is going to be the domain of the PDF. Okay, so I need to take a look at points x, z minus x. So if I add up these points, the x and the y coordinate here, they add up to z, so those points will fall under here, where this point here would be x, z minus x, and this falls on the line x plus y equals z. Okay, now clearly the sum z has to be from 0 to 1. This corresponds to x plus y equals 0. This line corresponds to x plus y is equal to 1. And so no matter what happens, the z that I choose must be between 0 and 1. Okay, furthermore, what are the boundaries for my possible values of x? Well, x must be between 0 and 1. Okay, so the x here must be between 0 and 1. And furthermore, the z minus x also must be between 0 and 1. And that implies that the x has to be between, well, let's solve for x here, so negative x is less than or equal to 1 minus z, less than or equal to negative 1, so x has to be between z minus 1 and 1. So that's a little bit more restrictive. Going along the line here, we see that x must be positive. And I think I made a dumb mistake here. Let me see what I did wrong here. Okay, well, anyway, here's what I want to say. X must be positive, so that's my x greater than or equal to 0. Furthermore, z minus x also must be a positive number. So that's what I've got here. And, oh, now I see what I did here. This should be a minus z here. And so x has to be less than or equal to z. And so those are my boundaries for the values of x. So x is going to be integrating between 0 and z of the PDF, x, z minus x dx. Okay, so stated another way, x, z minus x, these two, the x and the y coordinates add up to z, and so that's a diagonal slice going along a line like this. And because I must have x must lie in this triangle, the point x, z minus x must lie in the triangle, that means that the x values must be between 0 and z, so that both of these numbers are, in this case, positive, so it's inside the domain of the function. Okay, so this equals integral from 0 to z of the PDF. So it's 3 times the x-coordinate plus the y-coordinate, z minus x dx. And then it's just a matter of integrating this. So this is equal to integral from 0 to z of 3z dx. And so that is equal to 3 times z times x evaluated from z to 0. And so plugging in, we get 3z squared, and as long as z is between 0 and 1. So that is the PDF for the sum z. And you can directly integrate 3z squared and show that the integral from 0 to 1 of 3z squared is indeed 1. So this does check and is a PDF.